line of the document. So even though it says pads, power PCB, blah blah blah, so that's not a format that the program is
design
for.
So they need
So you need, yeah, sometimes you'll have to monkey around with this a little bit. So these are and so we know that it's a end signal, so we won't, so let's take this, Control C, and then let's see, do I have an editor open? Did I close the editor or something? Okay, open with Notepad. Okay, so I'm going to just say Control V. Okay, so I think it may actually be able to read through this until it gets to where it finds the net and signal. So I'm just going to, so this is going to tell the program which format it's looking for, and I may have to take these asterisks off of here. But let's figure it out. We'll figure it out together here. Okay, so now we'll try it again. So we go to netlist, test, cablescan. Okay, import complete. And so let's see what happens. Let's see, because it should get rid of all of this part stuff. So this is only a temporary file here, so we'll see what it does. Okay, so look at that. It's got all of the SIGs. It got rid of all the parts, and then it found all of the SIGs are all here. Okay, so we did it. Okay, so we have the net list is in here.
Yeah.
Okay, but remember how we talked about we may have a problem getting that resistor and diode to work, right? So one of the things, this is an important thing here. Okay, so now in general, what this program is going to do, if we let it, let's just let this go, and so the next step is going to be create wire list, and it'll take this and it'll create a wire list. Okay. Okay, so now, but what it's expecting, it's expecting that it's going to be able to see all these capacitor nodes and be able to actually measure from them, right? But it can't do that.
Yeah.
So the next step that we would do is we would say create export file. So it's going to take this cross-reference list. So these are the pins that it knows how to get to. And it's going to take this wire list, and it's going to find things that it can't get to. So it's going to say, I can't do this. So see all that blue? So those are all of the points that it can't get at. Okay, so how do we get rid of that? That's the thing that we need to do. Okay, so what we're going to do here is in the parameter area, there's this thing called filter reference designator. So this will be an important thing. Okay, so here we tell the program what things that it should ignore when it's looking at a net list. And so what it's going to basically do is say, if you get to this point, you aren't going to be able to create a point-to-point link. So it's looking, all of the ones that go J1 to J2, it's golden. It's going to do those, right? So, so what we need to do, and let's look at the net list here. So the net list is done, right? So you don't need to, or I'm sorry, the wire list. The net list is done, so we don't necessarily need to do anything here anymore. This is done. We know that the net list that we import, we can repeat that. So like if we screw something up, we can actually re-import that file again, and we'll be back to where we were originally. So, and then here's all the signal names. We don't care about signal names. What we want to be looking for is the points, right? The nodes. Okay, so what I typically do is, and so there's two things that happen in here.
Mm-hmm.
There's the wireless tab and there's a comp list tab. And these two things together, they work together to create the file that goes to the cablescan system. So and you guys have flexibility to use this tool the way that you want.
Mm-hmm.
But one of the standards that I do is I let the net list specify the things that show up in the wire list, and I don't put any components in there. Okay, and we'll go over why that is here as we're going along.
So you use the net list only for our net.
Well, but all
net
of
name only.
Yeah, well, and only, I mean, everything. So one of the things that this is all of the information for that board.
Yeah.
You know, so if I want to know where C5 is, okay, I can see that. I can search for C51, so I can actually find it in this net list, and I'm not going to mess with the net list.
Yeah.
But what I'm going to do is I am going to filter out. I'm going to filter out the R's. I'm going to filter out the D's and the C's. Okay, and I think I saw MTs also. I think I'm going to get rid of MTs as well. Yeah, I'll leave them in for now. Okay, so we go to parameters. And so what you do in the filter ref des, okay, so what you do is you put components separated by vertical bars.
Yeah.
Okay, so you start off with a vertical bar, and so I want to get rid of R's, I want to get rid of C's, and I want to get rid of D's. And so what that's going to do is any, like R1, R500, any of those things, this will all be in the file too. So you can come back and look at this file later and see what happened. Okay, so now we have this filter in here. Okay, so let's go back to the wireless. Yes. Okay, net list. Right. Yeah. So you go back to the net list. You don't need to import, but you need to create the wire list. So when you create the wire list, it's going to filter based on what we said. Mm-hmm. So we're going to create the wire list, and it's going to leave out the R's and C's and D's. Okay. So now we look and we see a bunch of J1s and J2s. Okay, here's some J1, M2. It's not going to know those, but that's okay. We'll let it tell us. Okay, so say create export file. And so it says, I don't know where these things are. I can't do these things, right? So
the blue one is not working.
Yeah, blue ones are ones where it has a problem. I think there's another.
If not working, then we can delete it, right? Directly.
And this is what we're going to do. Okay, sometimes you do want to edit the net list. And here again, you do it whichever way you think works better for you. Mm-hmm. You can certainly go in here. So these guys are called. So this is J1 pin M2.
Yeah.
Right. And so those pins there. So let's see. So if I tell it, here's these things called MT. So if I go back to the here, and I say,
remove MT.
I just say MT, and then we go back to the net list. We tell it to create a wire list. It's not, and so now we see. Okay, so now it's still not perfect. We say create export file. It says I still have problems. These three. There's no M1 or M2 pins on J1. Mm-hmm. So here it's kind of up to you if you want to find Control F J1-M2. Let's see where it is. Whoops, what did I? F J1 and M2. Okay, so So there's J1M2, J1M1, J2M2, J2M1. So it looks like if I get rid of this line, it will solve my problem, right?
Then we delete it.
So I can do it here.
Yeah.
But then if somebody in the future goes back and re-imports the net list,
Then
it'll come back and you'll have to do it again.
Yeah.
Right? So what I will do and what we'll do here, so yeah, I could delete it here and it will work for this.
Yeah.
But it's better to go back to here.
Program.
Let's go back to here and find that. Do we know what where was that? Did that have a signal name to it or what? Let's see. Net list begins following. Looks like, what's the deal here? It looks like there's something missing. Did I wipe something out? I may have wiped something out accidentally. Let's see. Because there should be a signal name here somewhere. So let's just re-import it anyway. I must have screwed something up. Test. Scan here. Open. That's complete. Yeah, see all of this stuff. I think what happened was I think I did this. I think I selected these things and wiped them out without realizing it. So now, so here's this signal, ground earth. GND earth is the one that looks like I want to get rid of. So let's go find that in here. Let's see. So we look and see. You can search for it. This is a small enough thing that there it is, ground earth. So if what I do is if I just do this, so that's ground earth. That's all of the signals for ground earth. If I delete them and then save it.
Import it again.
Exactly. So and now this is a net list that we're just using for cablescan.
Yeah.
We didn't screw up any net list that anybody in dot control will care about, right? So that's why we want to do this in our own workspace.
The purpose is we just want to filter the net list for cablescan.
Exactly. Exactly. Okay, so now let's read that baby in again. And
Just replace it.
And then, we'll let it overwrite it again. And now, it's not here. So now we say create wire list. And here's our wire list. And if we want to say create export file, it's happy. It says I successfully created the wire list. Okay.
So we want to look for the CVS file, right?
CSV
file.
I guess
That's the program.
It's actually an XLS file is what this. So, but what's going to happen is it's going to create. So since it's happy right now, it's actually going to create all of the things that you would need to actually load the program into the cablescan system. And so it says a file name, blah, 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 already exists. You want to replace it? Yeah, let's replace it. Most of the time I say yes. So now we have a program. So we can take this program
Put in there.
and the adapters, and we can test this on cablescan.
Yeah.
But what we don't have, let's see, do I have I keep closing stuff. Oh no, it's still there. Where Excel? Oh, I must have closed. I like PDF Exchange on my computer, and this thing is using the Microsoft app, and so that when I'm closing things, I'm killing it that way. Okay, so there it is. Okay, so here's our programming, or here's what it is that we're trying to do. So now, all of this stuff, all these point-to-point wires, all of this stuff is all tested. All of these point-to-point connections, but this stuff down here is missed. We're not getting that.
Yeah.
Okay, So we talked before about how this resistor diode thing is going to be difficult for cablescan. So we probably can't test these. We can't test this resistor or this diode because of that. But we can test these capacitors. Okay. And I mean, they're in parallel, just like, for ICT or anything else, they're in parallel. So you're not going to be able to test C1, right? But you can test C1 plus C2. And so what you're going to do is you're going to say, okay, so those go from J2 pin 9 to 24 comms. So you can just pick one, J2 pin 13. So what we can do is we can come into our program. So we have the wire list. This is all the point-to-point wiring. Okay, so what we want to do is let's create some components here. Okay, so we said that the capacitor is on pin 9, J29. So we can say from J2 pin 9 to, and then we're going to get ground from, let's say, J213. 2-13. Okay, and then let's see, does it have a, I think it has a legend in here somewhere. Okay, well, okay. So it's going to be, so this guy's going to be C1 plus C2. We'll just call it that. So it's C1, and so this is just like a signal name, so you can call it whatever you want. If it's a number, you may have to, this is Excel, so if it's a number, you might have to put a single quote in front of it to make it a comment instead of a number. Okay, so here's the comment, and then here's the component. Okay, so it's a capacitor, so we say C, and then orientation. So normally capacitors can be polarized or not. Mm-hmm. So it's going to assume that they're polarized, and so it wants to know the orientation. So it's going to say J29, is that going to be the plus or the minus? So you can just say, and I think here we will need a quote, plus, and then, so the nominal value is going to be 550 microfarads, right? So I don't know if it handles exponential stuff or not. So I usually use, so it's 550, so this is in farads, so it's going to be 0.00055 is what the capacitance is. And then the tolerance here, it's how with ICT sometimes you do the empirical measurement. You're not you may not be able to.
7% tolerance.
Yeah, but this thing with all the wires and distributed capacitance and all that stuff. So I don't usually do anything lower than 20%.
Yeah.
And I mean, we're not here to verify the capacitors per se. Yeah. We're just here, so the main goal of cablescan is to verify that the connector pin is wired up to the board. Mm. And so this is going to give me a chance to tell that J29 is connected to something, and it's a capacitor. And if somebody puts in a grossly incorrect value, you want to know it. But so let's just put in 20%, and then here, so you can put things in. Notice here, there's two things. It says you can have a low limit, high limit. So you could put the min max values in here if you want. Or you can put a nominal with a tolerance, okay? Mm-hmm. So low limit, high limit, that's a range. And then nominal tolerance, that's a tolerance. Oops, needs to be capitalized. E-O-L-E-R-A-N-C. And I typed it okay. All right. So, and I did spell it right. Yes, I did. And then we're going to create four capacitors. So this one's going to be pretty easy. So we say copy, paste. Okay, so now J213 is going to be the same for all of them, but then the other ones are going to be J2 9, 10, 11, and 12. So all we have to do here is we need to just go in here to say 10, 11.
11. Oh.
And 12. And then this one is
This is like
C3, C4, C5, C6. Okay, so
it's pretty much like fire protest.
3, C4. Is that right? I've never done flying probe tests.
Yeah.
I don't, yeah.
We do, but they more not manual, but they automation running the script quick.
And then, you know, these are kind of, the main thing that you're putting this in here for is that if there's a failure, the person that's running the cable scan has some information that they can use for troubleshooting.
Yeah.
Okay, so now, so we're going to say we can't test these guys. We've got all of this other stuff is already done. So we're just going to add these 4 capacitors in effect, and we're going to call it good. Okay, so we got that. That's all expressed in here. Now remember, in the wire list area, we had this we could create export file from here.
Yeah.
Okay, but since we added some components, we can do a create export file from here. Doesn't matter which one you do it from, but here we're going to create, oops, it's going to say blue, green, invalid parameter. So what was my invalid parameter? Oh.
Because you put the C and then
it corrected it for me. Yeah, that's just supposed to be a C. Delete. C.
Well, that Excel helping you.
Yeah, it helped me out just fine. Okay, good. That was a quiz to see if you noticed. Okay, so now let's try it again. So now it says, hey, I created it. Can I overwrite the file? Yes.
Oh, now
Okay, and so now it's
CVS
doing everything. So now everything. So now it's updated the whole cable scan program. Everything is all
Yeah.
here. So let's look and see. So here's the wire list and comp list. That's the ones that we used to create it. The cross-reference list was the mapping of the pins. So let's look here. This may be. Here's where the information is. So this is stuff that this is for cable scan. So if you wanted to add a wire, so if we look here, see how it's got the component type as a W. So this is saying that all of these are just wires. They're point-to-point connections. Okay, and this was the thing I was looking for before. So you can do wires, and then there's a different kind of wire here where you can give it continuity threshold, dwell time, test voltage. I've never used that. Resistors, and so remember I told you it's range and tolerance. So resistors, you can put range tolerance capacitors, and then these are the things that you want for that. For the orientation field there. So orientation field can be a plus or a minus, and then for a diode you put in an anode or a cathode. You say anode or cathode, and then it'll be there. It's all done. Okay, so this tab is mostly a help screen kind of sort of for you. Okay, this this is the file that's going to get sent to the cable scan machine. So here's all of the connections under what it's calling wires. So these are all the point-to-point, basically wires. And then here's the capacitors, okay? And then here's all of the cross-reference information. So cable scan is gonna say, oh, number 2, I'm gonna call wire number 2 is really called J1 pin 20. So this is telling the cable scan what the names of each of the inputs are for the system. So it's all right there. So 2 things, and I can tell Locke we probably need a break.
Oh no, the thing is I kind of see because they fail open a lot. Fake open.
Yeah.
This
well,
is the one.
So let me take a sidestep to this for just a quick sec. So the cable scan system has thousands of points, and they start off on a board in that big cable scan box, and it goes to these 64-pin cables, and then it goes from the 64-pin cable to an adapter to an interface on the board.
Yeah.
When you see some of these adapters, you can see they're kind of kludgy. People have done weird stuff to try and fix them and things like that. Mass terminator ribbon cables will pull loose and things like that. So you'll see, like Danny and the guys in test, they don't necessarily think of an open as kind of, it just kind of happens, right? It's just life. If we were doing a better job of making sure our adapters all worked, and there weren't any open pins. When it says open, it's not telling you that there's an open on the board that you're testing. It's telling you that there's an open between the pin that's plugged into the board and the adapter and the up to the cable scan machine. That's where the open is. So that's why what they do in test, what they're supposed to do in test, is if it says open, they take their DMM and make sure that those pins are in fact shorted together. That's what they're supposed to do with every open. And then if there's a short, then you have to go on the board and try and troubleshoot it and find out where it is. But shorts, they're tuned to they really get excited about shorts. Shorts are bad. Opens are they're kind of bad, right? So yeah. But that's kind of the next step when we're actually doing the test on the system. So let me see. So let's see here. So we created a program.
Yeah.
I'm going to show you 2 more things that we didn't use here necessarily, but I'll show you a couple of things that can come in useful. So like let's say that how do we do this? Let's say that the board has fuses in it. So like in this, if instead of this signal going from pin 1 to pin 1, that there was a fuse in this link, well, in the net list, you would see the fuse, F1 pin 1, F1 pin 2, okay, and so if you in a way a fuse is like a jumper. It's something that's supposed to be there. So you could but if what you did was if you went in here in the parameters and you put F in the filter reference designator, well, then that would just open everything up.
Yeah.
Okay. But if there's a fuse in there, so if there's a fuse, leave the fuse in, and then there's another thing here called merge ref des. Okay, and so what you can do is if you say F, is it? I'm probably still capitalized. So now what I did was I said if you find a component that's an F F1, F10, whatever. I want you to merge those. So I want you to connect. So if I see an F in my net list, I'm going to take F1 pin 1 and F1 pin 2, and I'm going to put them together to make it a short. So that way it just puts it all the way through.
Yeah.
So if you were going to do that, so you would just make this parameter called merge ref des. I don't know if you guys saw this, but in the wire list area, see this button called merge wires? So this button called merge wires, I can push it, it's not going to change anything because there's no fuses. But what merge wires will do is it would go and it would take, since I told it to merge Fs, so it's going to go through and find all of the Fs and it's going to merge them. And so they'll go away. So that way you get your connection.
Yeah.
There's another way to do that I've done. Sometimes instead of using the merge reference designators, you let the program take it out of the wire list. So it won't, those wires would go away. The J11 to J21 would go away completely because the fuse breaks it. And then you can go into the comp list and then you can say J11, J21, F1, and then you can say it's a resistor, and you can specify values. And this system doesn't have a lot of resolution on the wires, but you can say maybe 10 ohms, or so it'll test to make sure it's like 0 to 10 ohms, or you can put it in there as a wire. Let's look at the import file spec. So continuity threshold, yeah, I've never used that. So you could call it a W, you can call it an R. And then that way, so by doing it this way, by adding the F specifically, if the fuse is bad, the cablescan program will say F1 is open. Whereas if we do it by using the merge wires, it's going to say that J11 to J21 is open. And it's not going to know anything about F1 or any of that stuff. So that's the thing to kind of keep in mind as you're doing the program. All right. Any questions about this stuff so far?
Yeah. Our point is to filter the netlist, right, for cable scan test.
Yeah. So like if you've got a big so.
Do we know the format? So if we have a netlist, so I can filter offline.
Why?
Instead of you go a lot of steps to create by using them, using the tab to.
Well, I mean, this is actually pretty easy, right?
Yeah.
If you've got a net list, you can bring it in, and I mean, if you want to, you can filter out all the R's and C's and D's and LEDs and K's and everything.
Yeah.
And then run it, and then the program finds out all of the connections that it can test, and you're done. Right.
Yeah.
So it actually helps a lot.
Yeah.
And then the manual part of adding in resistors and capacitors and stuff as you do, it's totally up to you to program it however way you think. And you can also use the fact that that there's a functional test, right?
Yeah.
So that functional test is going to find certain things. So maybe I don't even care about the R's and C's because that they'll be caught in functional test. So it's all. It all is in your brain to figure out what sort of things that you want to do.
Yeah. Okay.
Anything, Kai?
So after this, where is the executable file for this one?
Okay, so yeah, let's see. Let me show you one thing really quick. And so remember how when we looked at the cable setup, it has this sequence, dB, all that stuff. Well, what happens if you've got a connector that's got some kind of a weird pinout definition? So what you can do is you can actually create a connector map. And we can go over this at some point in the future. So this is the connector map. So what you do is you can create a table here, and then that. Let's see. So let's look at the. Okay. So update. Let's see. Let's see what happens. Create map form. Where is the? I guess you have to create a map table to be able to pull it. So there are kind of standard mappings that have been created, so you can bring them in, you can pull them in. I'm trying to figure out why is it that I can't table name, update connector, blah blah blah, create map form. Why can't I load the open live? There we go. Okay. What did it just do? Accessibility, good to go. What in the world is this? Excel unlicensed product. Oh, okay. So here is the maps that have been done before. So like for instance, if you're using a 9007-075, well, somebody's already created a map for that. So you can actually retrieve that and put that into your table. So then you can just use that right away. You don't have to repeat, you don't have to redo the work that somebody else already did. We'll talk about that in the future.
Yeah.
It's a little it's a nice feature, but it's going to take time just to do the explanation of that. So, to get to your question, okay. So, where did this program go?
Go do cable scan test, right?
I don't think I need these things anymore. So we had. Where did we start? We started in
that job.
In the cable scan directory, right?
And then program.
F staff Chi, desktop Gerber 10. This is the assemblies. Did I close that guy? Oh, here it is. Cable scan test plans. This guy right here. So cable scan test plans. So now what we'll find, and we'll just tell it to look for date modified because we're going to be right on the top now. Okay, we go up here. Look at this. Okay, so we see there's 3 files here that go 0100 4379.
Mm-hmm.
So there's the Excel file. So this is the program that we're looking at, right? Let's get rid of that. Save. Okay, so this is the Excel file that we were looking at. This guy right here.
Mm-hmm.
So this is the main Excel file. And then here is something called export.xls. And, to be honest, I don't think this thing actually gets used. Let's see, open with. Yeah, so this is the export file, just in a slightly different format. You'll never use this. The file that you're going to use is this one right here, which is basically the same thing in an XLS document. Here, let's go over here. Okay, so this is what the cable scan system reads in, and so. These are all the parameters. If you look at the cable scan documentation, it'll tell you what all this stuff is. We don't care. All we care is that this is a file that we can load into the cable scan system and save the actual file. So I have the test write application on the computer at my desk. I don't have it on this computer, but you can do it out in the test lab also. So in the end, what you're going to do is you're going to take this file that comes out of the cablescan program, and then the program from cablescan called testwrite is going to turn this into the file that actually gets it loaded by the the cable scan machine, which is going to be in
They can open by the
It's-
software, right? Cable scan software.
it's called TestWrite. TestWrite
Yeah,
is
TestWrite.
the software. So yeah, so it's in F staff test, and then there's a test, and then we go down to TestWrite programs. So TestWrite HV, that's for the cable test, the out in the cable link area.
Yeah.
And then the regular TestWrite programs is right here, TestWrite program. So here's where all of the files that can get loaded into the cable scan machine get stored. There are these CDB files. These are the actual files that get installed in there. I think there's some kind of database program. I don't even know. Open with. It doesn't even know. I know that if you try to open it with a like a notepad or whatever, I don't think it's too. It's not human readable unless you have the right tool. So you now have a cable scan program. We don't have the board. So
we might have the board with the not completed, but we can try it out. We can plug in and try it out. Is that you load directly into? Did they open from directory?
So Danny doesn't have what he needs yet. He doesn't know how to open any of the stuff that we did. He only knows how to open these files.
Yeah, I know that they have the what they call icon. Test stands for that. Then open this one, then it's work. They connect with the adapter.
With these guys. Yeah. So this is these are all programs that get loaded into the cable scan machine.
Are we name it under what we name for that program?
So what we normally do, and you can see that there's not a lot of convention here, but let's look here. So normally what you'll see, and what I would normally do is this. Okay, so when we created it, it would be 0100 02186 Rev
assembly
004. Well,
Assembly number.
but most people don't type the rev in. So that's why you'll see this 0100 2129 underbar 002. That should be Rev 002. Or in this case, there's no Rev at all. Here's an 0100 02129. So the thing that's most important is that in your TI, you give the right name of the file that they're supposed to look for.
Yeah.
So that way there's no, if you put a rev in there, you put it in your TI and they'll know what to look for, however you want to do it.
So you put it here yet that program?
We haven't done that yet because we don't have TestWrite. You have a question, Kai?
Yeah, I'm confused. You go back to the Excel sheet, and how from the Excel become this one?
You need to use the TestWrite program.
TestWrite.
And
that's
then
the TestWrite program.
you load this file into
Yeah,
the
you
TestWrite, and then
load this in,
Uh-huh.
and then you save it to this.
Oh, and then you save it
And
from
then-
the
and then-
TestWrite to
exactly.
this one. Okay.
Yeah.
Okay.
So if you guys don't have any questions about this stuff here, we can go, since we don't have a board, we can do everything to get everything all ready. And then when they have the board, you can go out and test.
Yeah.
Because you know what adapters you need.
Yeah.
And you've done the program. So all you'll need to do is to put this into TI, and you shouldn't have to do anything.
Yeah.
But it's good to actually just be out there to validate it, and make sure that it works.
Yeah,
and
validate
stuff like
it
that.
only. That's why I have done that.
So if you guys don't have questions, if we go to my desk,
Yeah.
I have test write installed on my computer.
Yeah.
Yeah, I want to get it finished from A to Z, and then
Yep.
we delete it. We
Yeah.
do practice.